So in this module, what I'm going to do is talk about the ideas that you need to know from your previous courses. And what you're going to find is that the ideas that we use in this course draw from two main areas. One of them is your introductory statistics. And the other one is from linear algebra. I mean, we'll also be drawing from calculus as well, but the main sets of ideas and tools that we're going to be using in this course will be from probability and statistics and from linear algebra. Now, let's start with probability and stats first. And for many of you, this might be from CHEE 209, but doesn't have to be. But the kinds of things that you need to remember are things like random variables, and remember that there are two different kinds of random variables. There are continuous and discrete. And as you'll see in this course, we will link back to the kinds of variables that we actually observe in the world around us. And in one of the other videos for the course, we talked a bit about that. Second thing is you need to know about probability distributions. And remember, these can be continuous or discrete. We need to know about sampling and sample random variables. And sample distributions. And then from there, what we did was we generated confidence tests and hypothesis tests. Now, what do we actually use those on? Well, we actually use those to make inferences, to draw conclusions about values of parameters. And the way we actually estimate parameters like the mean or the variance is using a statistic. So we need to go back and remind ourselves what we mean by a statistic. So those are the probability and random variable and sampling type things that you need to know from your introductory statistics course. You spent some time thinking about the mean and variance and how we actually estimate those with the sample average and with the sample variance. And so the principles that you actually applied in thinking about where the uncertainty lies in the case of the mean or the variance apply equally when we start estimating parameters in a regression model. So we'll go back and you'll need to remind yourself how all of that works. We're going to touch on some of this in CHEE 418 as well, because we will derive again the confidence intervals for parameters in an estimated model, and we'll be doing hypothesis tests. But it would be very helpful if you can go back to your first course and actually remind yourself of how all that works. So in your first course, you may also have done straight line regression. Okay, and I'm sure that somewhere in the various courses you've taken, you've estimated models that look like this, where this is the noise term in the model. We're going to spend some time talking about that noise term again. So those are the ideas from probability and statistics. From linear algebra, the things that you're going to need are, first of all, remember how to work with matrices and vectors. Okay. And things like matrix multiplication, inversion. So if I've got a matrix X, how do I calculate X inverse? That kind of thing, the determinant of X. Because one of the things that we'll do in this course is come up with an expression for the parameter estimates in a multiple linear regression model, and it's going to look like this. Okay, and the y's in that equation will be the observations. The X matrix really is going to contain all the values of the factors, the independent variables, or the explanatory variables. And so those will be put in a matrix form. Remember that that little T stands for transpose. So you need to remember how that works. And the other thing that we're going to do is we're actually going to focus on this quantity here, X transpose X. Because it turns out actually that that X transpose X has a lot of useful additional information. So on one hand, what we're going to do is we're going to see that the experimental design that we use so in other words, the choice of run conditions, if we're running a bunch of experiments, has a significant impact on the structure of that X transpose X. And the structure of that X transpose X has a significant impact on our ability to make independent conclusions about the values of the parameters. Because if we're not careful about how we do our experimental runs, we may find that, for example, the estimate of the intercept and the estimate of the slope have a lot of correlation. And so we can't draw one conclusion about whether the slope's significant or not without having an impact on the conclusion we might draw about whether the intercept is significant. So that's one important area of consideration, is that we can choose our experimental runs in order to dictate the structure of X transpose X and help ourselves when we try to draw conclusions from our modeling. But the other important role of X transpose X, and this is especially if the values that we have in the X have come from historically collected data, is that this X transpose X also summarizes, if you want, it's related to the correlation between the X's. And so what we're actually going to do is use something that you did in your first year linear algebra course, so eigenvalues and eigenvectors. And so it turns out that if we actually come up with the eigenvalues and the eigenvectors for X transpose X, so if we take X transpose X and we look at the eigenvalues and the eigenvectors, we can gain insights into what quantities in the physical data that we've recorded have some sort of a systematic relationship. In other words, they tend to move together. In other words, we can pick apart correlation patterns. And this is actually a technique that's used quite often now in data mining, and it's referred to as principal components analysis. And very often people just use the acronym PCA. So that's another thing that we're actually going to use linear algebra for. So this pretty much gives you the main set of knowledge that I want you to carry forward from your introductory courses in linear algebra and in probability and statistics. I will have some videos that give some background or refreshers on pieces of those, but I am expecting you as well to go back to whatever your intro courses were and review the key concepts as we use them in the course.